Hello class, today we're taking a look at putting some fractions and decimals on number lines. So we want to remember that the first thing we need to look at on our number line is how many ticks are between two whole numbers. So if I look at part A here, we always start our ruler at 0, and then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ticks up to the next whole number. And what that tells me is that the bottom of every fraction on this number line is 10 to begin with. As far as the top of the fraction, we just need to count how far we are from the whole number on the left. So B is 1 spot, so its fraction is 1 out of 10. C is 3 spots, so it's 3 out of 10. D is 7 spots, so it is 7 out of 10. And A is 9 spots, so it is 9 out of 10. As far as our decimal goes, all of these fractions already have a denominator of 10, which means that all of their decimals will reach the tenths place. We know we fill in our digits starting on the right, and any other digits with a 0. So 9/10 is 0.9, 1/10 is 0.1, 0.3, and 0.7 for 3/10 and 7/10 respectively. Now we're going to follow the same approach for part B. So first off, we're going to count how many ticks, 2, 3, 4, 5, between two whole numbers. That tells us that the bottom of our fraction is 5 to start out with. And then our top of our fraction is where we are. So C is at tick 1, D is at tick 2, A is at tick 3, and B is at tick 4. Now, fractions out of 5, you are supposed to have those decimals memorized, but if we weren't sure, we could of course convert them to having a denominator of 10. And once we have a denominator of 10, we know that our decimal will be to the tenths place. So 6/10 is 0.6. We're going to also multiply by 2 here. We'll get 8/10 or 0.8. Multiplied by 2, we get 2/10 or 0.2. And multiplying by 2, we get 4/10, which is 0.4. Same thing in part C, same process. So let's count how many between each set of whole numbers. So 1 tick, 2 ticks, 3, 4, 5, 6 make up one whole. So we know the bottom of every fraction is a 6 to start out with. So if we fill in our tops, A is at tick 1, C is at tick 2, B is at tick 4, and D is at tick 5. Some of these fractions we can reduce, so we should do that. I'm going to reduce the fraction for B because both of them divide by 2. That gives me 2/3 as the reduced fraction. I can also reduce C, gives me 1/3 as the reduced fraction. And my other 2A cannot reduce. 1 doesn't divide anything, and 5 doesn't divide anything either. Okay. Now to convert these into decimals, these are a little bit trickier because 6 cannot be multiplied by anything to give you 10, 100, or 1,000. So in the case of 1 out of 6, we are just going to need to long divide there. We need to divide 1, which is 1.000 as many times as you need. We need to do 1 divided by 6. 6 goes into 1, 0 times, decimal. 6 goes into 10, 1 time, creating 6, taking away leaves us with 4, bring down the 0. 6 goes into 40, 6 times, leaving us with 36, taking away leaves us with 4. And you might notice we're now in a loop. So 1/6 is 0.16 repeating. Notice the repeating bar only goes over the 6 and not the 1. For our middle two, we don't actually need to long divide these because we can use a little trick and multiply by 3 to end up with 6 out of 9. And our rule is that if we have a 9 on the bottom of our fraction, it is that digit repeated. So 6/9 is 0.6 repeating. 3/9 is 0.3 repeating. So those two are relatively easy. Our last one here, 5 out of 6, we again probably need to long divide that one. So we're going to divide 5 by 6. And remember, 5 is 5.000 as many times as you need. 6 goes into 5, 0 times. 6 goes into 50, 8 times, creating 48. Taking away leaves us with 2. 6 goes into 20 3 times, creating 18. Taking away leaves us with a 2, and we're now in a loop. So we know it's 0.83 repeating. Again, notice the repeating bar only goes over the 3 and not the 8. So of course, if we cannot use our fraction tricks to create decimals, 10, 100, 1,000, or 9, 99, 999, we are just going to long divide to create those decimals. Part D, let's start off by counting the number of ticks between two whole numbers. So I'm going to count between 4 and 5. My ruler always starts at 0, 1, 2, 3, 4 ticks in a whole number. And C is at the third tick out of 4. So as far as our fraction goes, we do want to notice that we're, higher than 1. We're above the whole number 4. So we're going to have whole number 4 and 3/4 for our part C fraction. If we wanted that as an improper fraction, we can of course multiply our whole part by our denominator. That would be 16 plus 3 is 19 fourths as an improper fraction. A is 2 ticks past 5, so it is going to be 5 and 2/4. We can simplify that to 5 and 1/2. And if we wanted to, we could convert that to an improper fraction. 5 times 2 is 10, plus 1 is 11/2. B is 1 tick past 7, so it's 7 and 1/4. We know that that is going to be 7 times 4 is 28, plus 1 is 29/4 as an improper fraction. And D is 1 tick past 6, so 6 and 1/4. Which is, 6 times 4 is 24, plus 1 is 25/4 as an improper fraction. For our decimals, let's go ahead and think about these. For our 11/2, or 5 and 1/2, that is 5.5. I know that because 1/2 is 0.5. Of course, I could convert that fraction to be an out of 10 as well, and I get 5 and 5/10. And that's where we get our 0.5 there. 1/4 we know is 0.25, so 7 and 1/4 is 7.25. 3/4 we know is 0.75, so 4.75 is our decimal. And again, 6 and 1/4. 6 and 1/4 is 0.25. We want to put these fractions on the number line and put a point on the line and write the original fraction above. So let's first off see what they've given us as far as a number line. We're again going to count our ticks between 0 and 1. That's one whole. So we got 1, 2, 3, 4, 5, 6, 7, 8 ticks. Which means we want all these fractions to have denominators of 8 to be able to put them on the line. So let's go ahead, we'll multiply the first fraction by 2. That'll give us 2/8. So right at 2/8 is our fraction 1/4. We're labeling that with our original fraction, obviously. For our second one, we have to divide 16 by 2 to get 7/8. So that is our second fraction. Again, we're going to label it with the original fraction. I guess they told us original fraction above, but that's fine. 1/2, we're going to multiply it by 4 to create a denominator of 8. So 1 times 4 is 4, and 2 times 4 is 8. So here is our position of our 1/2. And then 5/8 is already out of 8. So we'll just label that one 5/8. Okay, again, notice that our labels on the number line are using the original way that the number was written, not using the converted way. Use the number line to plot numbers, write the original numbers. So if I look at all my numbers here, all of them are proper fractions, which means all of them are between 0 and 1. Now if I think about what I have here, everything 12, 3, 6, and 12 can be written with a common denominator of 12. So I'm going to set it up where there are 12 spaces between 0 and 1. So obviously we start at 0, then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm actually going to replace where my 1 is. because it should be at that 12th approximately equal division. I know my divisions aren't perfectly equal here, but we kind of imply that they're of equal spacing. So obviously this is 1, 2, 3. Let's just check. Perfect. 12 spacings make up one whole. So 11 out of 12, that one's going to be easy. It's just at spot 11 out of 12. 1/3, we're going to need to make a denominator of 12. 3 times 4 is 12. Let's multiply the top by 4 as well. So here's our 1 out of 3. 1 out of 6, we need to multiply the bottom by 2 to create 12. And so we'll multiply the top by 2 as well. And then 5 out of 12 is already written for us. So it's just at location 5 out of 12. So that is your little practice sheet for our number lines.